Hello, this is Dr. Amudapriya, Associate Professor Triply from Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Operation and Control, and in this lecture we will discuss about the Unit 3 regarding Reactive Power Voltage Control, and this lecture will deal with the excitation system. So what is an excitation system? The basic function of an excitation system is to provide necessary DC current to the field winding of a synchronous generator or an alternator. The excitation system must be able to automatically adjust the field current in order to maintain the required terminal voltage. The DC field current is obtained from a separate source, that is called an exciter. The excitation systems have taken many forms over the years of their evolution, and the following are the different types, namely DC excitation systems, AC excitation systems, brushless AC excitation systems, and static excitation system. So while considering the DC excitation system, the field of the main alternator is fed from a DC generator called exciter. Since the field of the alternator is in the rotor, the required field current is supplied to it through the slip rings and the brushes. The DC generator is driven from the same turbine shaft as the generator itself. So normally this type of DC excitation system has a slow response. Normally for 10 MVA alternator, the exciter power rating should be 20 to 35 kilowatt, for which we require huge DC generator. For these reasons, DC excitation systems are gradually disappearing. They are being replaced by the next type of excitation systems. Here we can see this is the excitation system where we do have the exciter field winding in parallel to the DC generator armature. Next, let us see about the AC excitation system, in which the DC generator is replaced by an alternator of sufficient rating so that it can supply the required field current to the field of the main synchronous generator. In this scheme, obviously, a three-phase alternator voltage is rectified and necessary DC supply is obtained. Generally, two sets of slip rings, one to feed the rotating field of the alternator and other to supply the rotating field of the synchronous generator, are being required here. So this is what is the excitation system block diagram. Next, in case of brushless AC excitation system, an old type of AC excitation system has been conveniently replaced by a brushless AC excitation system because it offers many advantages, wherein an inverted alternator is used as an exciter here. Inverted alternator or nothing but which is having a field at the stator and armature at the rotor. A full wave rectifier will convert the exciter AC voltage to DC voltage obviously. The armature of the exciter, the full wave rectifier and the field of the synchronous generator form the rotating components. The rotating components are mounted on a shaft. So this kind of brushless AC excitation system can be obviously seen here. So we can see we do have the stability compensators here, and is then after comparator, and this is a feedback here where we do have a comparator, and after that we do have an amplifier where the exciter is being provided, and this exciter output is then rectified and finally given to the alternator. So in this way, brushless AC excitation system favors the machines. And next, the static excitation system is named as a portion of the AC from which each phase of synchronous generator or alternator output is fed back to the field windings as DC excitation through a system of transformers, rectifiers and reactors. In this case, an external source of DC is necessary for initial excitation of the field windings. So the engine driven generators, the initial excitation may be obtained from the storage batteries in order to start the engine. So this also bears a certain disadvantages. Overall, while comparing, brushless AC excitation system is proved to be a better one.